This is section 9.1, developing formulas for triangles and quadrilaterals. Objectives: develop and apply the formulas for the areas of triangles and special quadrilaterals. Solve problems involving perimeters and areas of triangles and special quadrilaterals. No vocab. Next slide. Let's look at this postulate. It says it's called the area addition postulate. The area of a region is equal to the sum of the areas of its non-overlapping parts. Keyword here, non-overlapping. So let me give you an idea what this is talking about. Let's say that you want to compute the area of this shape here. If you apply postulate 9.1, first you compute the area of this rectangle. This is 2 by 4, whatever area that is, and then you compute the area of the other part, which is this squared. Once you compute the area of these two non-overlapping parts, you have the area of the shape that we started with. Let's move on to the next slide. This is the area of a parallelogram. You probably have seen this formula, but it's right there. It's just the base times the height. And where does the formula come from? Look at this illustration. Notice that this is the parallelogram right here on the left hand side. Now if you were to cut this piece and put it over here, what does it make? It makes a rectangle, and this is how you find the area of a rectangle. So this is where this formula comes from. Just something for you to remember. Next slide. It says find the base of the parallelogram in which h is 56 yards and the area is 28 squared yards. Excuse me. The area is equal to base times height for a parallelogram. You substitute. So in order for you to solve for b, you need to divide both sides by 56. And this is how you get b, either 0.5 or half a yard. Next one. Find the area of the parallelogram. So you're looking at this right here, this area. In order for you to find the area of this parallelogram, you need to know the base and the height. Notice that the base is right here. Let me change the color. This is your base. And of course, you don't have the height. It's here. So we'll call it h. How am I going to find this height? Hence, we have a right triangle here. This is 34, the hypotenuse. So that's why I apply the Pythagorean theorem. You should be able to follow this pretty easily. And then at this point, I know that I get h is equal to 16. Now that I know my base and the height, I can apply the formula. And this is the answer. 176 square millimeters. Number 3. Find the perimeter and area of the rectangle. In this case, excuse me, notice that you don't have actual real numbers. You have algebraic expressions, but nothing that we cannot handle. Let's first compute the perimeter. You know this is the formula to find the perimeter of a rectangle. This is what is going to be my base. This is my base, and this is my height. So I substitute, simplify, and this is what I get. 4x minus 6 feet. Now I compute the area. This is a rectangle, so it's base times height. So I'm going to multiply x minus 5 times x plus 2. I have to FOIL here. And this is what I get. X squared minus 3x minus 10 square feet. And again, it's an algebraic expression. Let's move on to the next slide. These are formulas that you probably have seen. So the first one is how to find the area of a triangle, which is based on height divided by 2, and the trapezoid is right here. Notice that they gave you two different forms, but it's basically the same thing. If you talk to me in class, I can show you why this is the formula to compute the area of a trapezoid. And it has to do with the area of a triangle. Just let me know, and I'll be more than happy to clarify it. And it's kind of neat how it's done. Let's move on to the next slide. It says find the area of the trapezoid in which B1, which is basically saying base 1, the first base, is 8 inches, the second base is 5 inches, and the height is 6.2. So here's a picture of the trapezoid. This is the formula. I substitute the values. Let's do some computation here, and this is what we get. 40.3 square inches. 5. Now in this case, you don't want the area. Here, you need to find the second base of the trapezoid, and they give you this information along with what you see here, the height. So then all I'm going to do, again, I use this formula. I substitute the given information, and hence, since I'm looking for B sub 2, the second base, this is what I have. So what I do is I divide everything by 11, and I get this. Now, I don't want this 1/2 here, so what I'm going to do is I'm going to multiply both sides by 2/1. Excuse me, 2/1. Once I do that, I just have 23 plus B sub 2. This becomes 42, solve for B sub 2, and this is what I have. 19 millimeters. Next slide. The area of the rhombus or kite with diagonals D1 and D2, or D sub 1 and D sub 2, is given by that. So for these two shapes, for the rhombus and the kite, we actually have the same formula, which is what you see here. Remember, these are diagonals. Diagonals. And you know that these are 90-degree angles. We have talked about that. That's what I just said. Okay, let's move on to the next slide. Find the area of the rhombus. So in this case, we're going to use the formula you saw on the previous slide. This is your first diagonal here. This is your second diagonal. So I apply that formula. I substitute. I have to FOIL here, and you should feel comfortable with the idea of FOIL. You did that in Algebra 1. This is what you get, and then at this point, what I'm going to do is I'm going to distribute the 1/2 into this trinomial. Once I do that, this is my answer. So this is the area, square centimeters. This is the last problem. It says find the area of the kite. So in order for you to find the area of the kite, you need the diagonals. And I have the distance from here to here is 28, but I do not know this. The distance from here to here is y, and I don't, which is the same thing as, let me start again. If this is y, this is also y. Okay? I'm given 28, like I said here. You also have the following side of the kite and the other side of the kite. Given the fact that I know this is 90 degrees, this is what I'm going to do. I'm going to find x and y using the Pythagorean theorem. So here we go. Let me highlight the y. So I'm going to find y first. And basically what I'm doing, I'm looking at this right triangle here. And again, this is 90 degrees. So once I apply the Pythagorean theorem, this is what you have. Pull out the calculator, square, solve for y squared. You have the following. Take the square root of both sides, and you end up with 21. So now you know that this is 21. Now I find x. Let me highlight the right triangle that I'm using to find x, which is right there. Again, 90 degrees. If this is 29, you know that this is 29. And, excuse me, if this is y, this is also y, and we know that this is what y is equal to, so this is 21. So that's why you see this. Once I simplify this, I get x squared equals 400. I solve for x. I take the square root of both sides, 20. From here, almost there. D1 is 48. I'm calling this D1. And this is D2, 42. So to find the area, I apply the formula you saw on an earlier slide, which is right here. And this is the answer. 1008 square inches. And this concludes the video for section 9.1.